Good afternoon and welcome to today's webinar. Today's webinar is hosted by Capacity Magazine. My name is Nadine Hawkins and I am the editor. I'm joined by Patrizio Pranici, who's the Europe, Middle East and Africa lead at Bloom Energy, and Alessandro Viviani, Associate Partner at the European House Ambrosetti. Before we dive in, a quick bit of housekeeping. This session is being recorded and will be available on Capacity Media's website after the webinar. If you have any questions throughout the webinar, feel free to type them into the chat box and we'll be addressing as many as we can at the end during our dedicated question and answer session. As the demand for AI, ML and cloud computing continue to drive unprecedented growth, data centres face critical time to power challenges, with grid constraints, delaying deployments and increasing costs. Based on a recent survey of decision makers in hyperscale and co-location developer companies, we are seeing a growing shift towards on-site power generation as a primary power source. Today's webinar will explore how innovative on-site power solutions are reshaping the data center power landscape and how energy buying decisions are evolving beyond cost considerations. We'll discuss how you can optimize power strategies for faster deployment, and you will gain critical insights into factors influencing power technology choices and learn how to achieve sustainable growth while meeting operational and environmental targets. Alessandro, I'm going to start with you. AI is driving an unprecedented surge in demand for computing power. If we look beyond 2030, particularly in Italy, how do you envisage the data center landscape evolving to support AI at scale? And what major changes do you anticipate in how we design or power these future facilities?
Thank you for this important question. Let me say that before stepping into AI, what we can see is that the digital service demand, especially the cloud, is sustained by a very strong fundamentals. And I have also a slide here to share that clearly depicts that in the largest regions in the world, we are, running out of available capacity. Here is, the main regions in America and in Europe, and you can clearly see that despite the increasing of the IT capacity, there is a strong decrease in the vacancy in all the main regions. And then when we come to the topic of artificial intelligence, Gartner recently said that about 40% of data center will face operational challenges and constraints by 2027. What I would like to say is that AI is increasing, but the real question is what will be the real adoption of this technology? What will be at the very end the real adoption from the final user? And we know that there is some concern about that, about the capacity from the demand to create a rise in the demand. But on the other side, what we can see is that artificial intelligence is increasing year by year, day by day. Let me say also what are the real kind of capacity, and we should carefully look at what are the next kind of artificial intelligence, what will be also the changes in the capacities and the performance of the data center that we need to take to clearly understand. Different artificial intelligence have different data infrastructure requirements. Here we have the example of what is now the hype, the AI agentic. There is a clear trend that is going to be the real game changer within companies, within the business in terms of adoption of the artificial intelligence. But this will require a new balance between the centralized data center and also the distributed data center, because company will need to work with a language model within their environment, within their data infrastructure. This is also coupled with a topic. We have now something that between 50 and 60, at least in Italy, of data of the companies that rely on premises infrastructure. This won't be stay longer because, of course, a security issue on one side, but also they need to increase the performance of those kind of infrastructure. So this will be a clear demand pattern for data infrastructure in the future related to the both on the NIS2 in Europe or to the agentic artificial intelligence. Finally, what I would like also to stress is that when it comes to artificial intelligence, we will have also a change in the power patterns of the data center, in the way they consume energy and the way they integrate with the energy infrastructure themselves.
Patrizio, this one is for you. Building on that future vision from a power and infrastructure standpoint, what should data center operators across Europe, Middle East, and Africa be doing today to prepare for that world? And are there any specific strategies or technologies you believe they need to invest in now so they can scale up for AI workloads over the coming decade, but while still staying resilient and sustainable?
Yeah, well, the data center operators are already building infrastructure designed for scalability, resiliency, flexibility, and sustainability. The main challenge of the data center operators today, the challenge they are facing in Europe, is the availability of reliable grid connection with sufficient capacity to provide the power they need where the data center is located. Okay. So, I'm sure that those challenges will be solved in the next decade when the grid operators will be able to build new transmission lines and solve the grid problems they are facing today. There are investments in the plan, but, building grids in Europe is a challenge because bureaucracy. And so, the budget is there, the willingness is there, and it's a matter of time. And at the time, the grid will be able to provide the reliable and sustainable power the data center majority, needs, and those power would come from renewable energy sources. But, the question is today. In my opinion, the data center operator should invest today in on-site power generation solutions, meeting the criteria we have discussed before, and waiting for the grid operator solving their issues and providing reliable and sustainable power to the data center. This on-site power generation solution can be either permanent or temporary, but for sure, they should be, as the data center, scalable, resilient, flexible, and sustainable. I'm personally a firm believer that the best solution for enabling the data center infrastructure in the context today is the Bloom Energy servers that can be available for purchasing in case, we are talking about the permanent solution, or rental. The rental solution will allow the data center operator to deploy their own business quickly, start making money, and then, getting the green power from the grid when the problem will be solved. So, for me, the answer is the Bloom Energy solution, which is scalable as it may grow together with the data center growth. It is resilient as Bloom can guarantee up to 99.39% power availability at any time during the operation of the power plant. It is flexible as the Bloom Energy server can support with no issue the load variation requirements of the new artificial intelligence data center. It is designed for this. And it is one of the fastest responding technology to load ramp up and load variation. This flexibility is coming at no cost for the operator, as the Bloom Energy server still keeps almost the maximum electrical efficiency, even when technology is part loaded from 60% to 30%. It is sustainable due to the fact that there is no combustion, NOx and CO emissions are negligible. No emission or variable organic compound, unbound hydrocarbons, particulate, and methane slip. CO2 is easy and cost-effective to be captured. Last but not the least, Bloom can use 98% of the material of the exhausted fuel cells to build new product. I haven't seen another technology with such higher level of sustainability.
Alessandro, now turning to the energy challenge, many say energy has become the new bottleneck for data center growth. What do you see as the biggest barriers to investing in the power capacity and green energy that modern data centers need? And I also know that there's an access to power dilemma in some regions. Can you give us a little bit more information about what that looks like, especially in Italy, and how it impacts on data center expansion?
Yeah, thank you. First of all, I totally agree with Patrizio that the problem is not the energy itself, but is the power connection. But on the other side, not really sure that we will never have the enough network capacity. Take into account all the development under the electrical point of view in the different domains, from the production till the different kind of consumption domains. I just provide you a few numbers that come from Italy, just to provide you a reason why energy is not the problem, but is a problem of capacity. By 2028, the amount of renewable energy capacity in Italy is projected to rise by more than 40 terawatt-hour per year, while the consumption of data centers is projected to rise about 6 terawatt-hours. So a lot less than what is the requirements. In the last few years, the demand of electricity from the industries in Italy rise by 8 terawatt-hours, more than the data center. No one complained about that. No one put any scandals on newspapers. The problem is that the development of a data center will require massive investment in the network. And this is a social also problem. It's also a topic as a social relevance. Let us come to the current situation in Italy. I would say that Italy is also attracted investment, not only, but mainly because there are still availability of former industrial sites with at least 10, 20 megawatt of connection already available. But the situation that I see now is, let me call it this way, a little bit of for West. There is a lot of confusion of different kind of developers and operators that are running to find this kind of brownfield in the former industrial areas. And this led to a lot of confusion and for sure a very low capacity for the energy system to adapt. Just a number, currently the Italian Terna, the transmission system operator for electricity, collected something like 45 gigawatt hour of connection requests, while the scenario for Italy in terms of installed capacity of data center is something that is ranging between 1 and 2 gigawatts by 2030 and something ranging from 6 to 9 gigawatt hour by 2040. So there is a complete displacement between those two numbers. And I come to what is, in my opinion, the main message of my presentation, and I leverage on these slides that the current model that is pursued by the developers of data center is the main limitation to the investments. The need to have from the time zero full sustainability, 24/7 renewable electricity, and to have a connection to the grid, and 100% network electricity power supply, is the most difficult model to be deployed currently. Even considering then the brownfield areas are gonna to over in the coming months. There are several reasons why. So the time to power in Europe is rising more than 5 years. There are increasing network instability, see the Spanish blackout. There are restrictions on the construction of data center due to a higher share of electricity on the total consumption. There are access to renewable energy that is in competition with the other industrial consumers. So there is an increasing trade-off between the different consumers. And also there is some restriction on the capacity to use different form of backup technology, especially the diesel technology. All of these criticalities led to the need to revise the current model that is preferred by the developers of the data centers.
Alessandro, I know you've also advocated for a technology neutral approach to meeting data center energy needs. How can embracing technology neutrality help accelerate the deployment of sustainable power solutions for data centers? And do you have any examples of how a tech neutral policy has enabled faster or broader adoption of clean energy in the industry?
Yeah, thank you for this question, because technology neutrality is a long-lasting crusade from our side. We started in the 2019 working together with ENI at the Italian and European level in promoting the principle of technology neutrality within the energy transition. And year after year, so also the policymaker start moving on our side. At the very beginning, it was not easy, but now the facts, the need for competitiveness in energy, the need to not neglect investment in face of sustainability is giving us more and more importance on this principle. But what does it mean for data center? It means that we need to leverage all potential technologies, as the one that was presented by Patrizio coming from Bloom Energy, to achieve a single principle. We call it this 10 euro cent per kilowatt hour in 10 months. If we want to attract investments in Italy and in Europe in general, we need to be able to offer the possibility to access a competitive energy less than 10 cents of euro per kilowatt hour in no more than 10 months. Otherwise, investment could flow in other places. To do this, we need to act leveraging on two main drivers. The first one is to create business models that integrate the data center with the renewable and energy business model in general. And the second one is to leverage more and more on-site generation, sustainable gases, carbon capture and storage. I just provide you numbers. In Italy, the capacity of the gas network is 10 times higher than the electricity network. So this new kind of technology could leave also the possibility to transform what is currently perceived as a grid reliability to a grid assets, a problem into our resources. And in this way, we can change also the narrative concerning data centers, and we can also change the way in which the data center create a stronger dialogue with the energy system, especially with the network operators.
Patrizio, I'll jump back to you. From the technology provider's perspective, one practical issue is the time to power challenge, which we're hearing a lot about just now. We often see data center projects delayed by long waits for grid connections or power upgrades. How have you seen this time to power issue affecting projects, especially those building energy hungry AI facilities, and what solutions can help new data centers get the necessary power faster?
Well, yeah, the answer to the question is yes. We always see data center project being on hold or delayed by either the missing the grid connection or the long time to get the grid connection, which, by the way, if and when it's coming, will never have the power capacity needed by the data center. So, as I told you before, I think the data center operators should invest in a kind of bridge technology, allowing them to deploy the business fast and then, getting the power needed through the grid when the grid will be available in the quality and time, in quality and size they need. Short time to power is one of the main values added to data center by the Bloom Energy Server. Bloom can deploy power plants for artificial intelligence data centers, which has a size of 100 megawatt approximately, in 6 to 9 months in Europe, from a contract or commitment date. While the other technology, such as reciprocating engines or gas turbines, need more than twice this time or even longer. If we consider, this 6 to 9 months may perceive too short, but in reality, if we consider the project schedule, composed by 3 phases, okay? Permitting, procurement, and construction. The Bloom Energy Server design allows the data center operator to reduce, the time of each one of the steps in weeks. Regarding permitting, because the Bloom Energy Server, the fuel cells technology, has very low environmental impact, okay? So NOx and CO emissions are negligible. No emissions of volatile organic compound, unburned hydrocarbons, particulate matters, and methane slip, low noise emission, no invasive exhaust stacks infrastructure. The Bloom Energy Server has been granted environmental impact assessment exception in few European countries, okay, which are the countries where we have applied for it. So, we have established a nice precedent in Europe that can be leveraged in any member country, and it reduces the permitting process that is typically taking from 12 to 18 months to maybe 12 to 18 weeks. Regarding procurement, we can ship energy servers in weeks as we are in full control of our global supply chain and resources. The fuel cells are printed and painted in our headquarters in San Jose with very high robotized machineries and shipped to our assembly facility in the Delaware. Electronics manufactured in our factory in India, and they got shipped to Delaware as well. So, our people are working hard to assemble the things that we do and shipping to customer in weeks from the East Coast of the United States. And nothing of the components we are using is crossing, the global supply chain of the other guys that, as we all are aware, they are struggling in keeping their own commitment on delivering the order they signed even 2 or 3 years ago. Regarding construction, if the energy server is not stuck, we don't need civil works, and the energy server got shipped to fully assembled in the factory. So upon arrival on site, customer has to place the module on a compacted ground and managing 3 connections. I would say 3 simple connections. The natural gas connection, which has a pressure of less than 1 bar. And in Europe, this means a lot because you don't need to be compliant with the nasty and requirements of the European Pressure Vessel Directives, PED. 1 connection of water, which is used for startup only, and the power evacuation, which is 400 VAC. There is no need of lifting equipment for the lifting of the energy server, which can be transported to site on standard trucks, and because it has shipping dimension of a standard shipping container for marine cargo. And installation of commissioning of these things is completed in days. I would say 10, 14 days, unless there are some, specific boundaries of complication outside. So time to power is the main value we can bring to data center operators to deploy their own business as fast as they can.
And Alessandro, energy efficiency and material circularity are becoming increasingly important for sustainable data centers. How critical is it for operators to adopt international best practices in energy efficiency and to embrace circular economy principles?
Thank you. We all have a lot of focus on PUE as a main indicators of efficiency and a lot of chat on that. We know that now the average PUE of the current state capacity is ranging between 1.5, 1.6, but we have best practice that, can go lower than 1.3. We have just made a very easy what-if analysis. What could it mean in Italy by 2040 to ensure that we will have an average PUE of 1.3? It means that the data center will need, they will need something like 50,000 football pitches of photovoltaics. It's an enormous amount of energy, it's an enormous amount of social impact, environmental impact that is avoided. So first of all, efficiency first. But we need also to look, outside the PUE. What is the overall efficiency of the energy system to serve the data center? If we look at the currently electricity generation in Italy, we have more than 10% of losses in the network. And then we have something that is more than 50% of losses in the power generation by gas. If we are rising the total share of electricity that in Italy is consumed by infrastructure like data center, we need to take into account on how to serve this infrastructure in the most efficient way. And on-site generation, leveraging on fuel cell is the most efficient way we can serve this kind of infrastructure. So this is my first point. When it comes also on the topic of efficiency, even with a PUE of 1.3 by 2040, in Italy we will generate as excess of heat enough to provide energy to 2 million households. It is an enormous amount of energy, and there is a question what to do with this heat. I'm not sure district heating is the right answer. I will go on this topic later. But even in this case, the topic is to lower as much as possible the energy that is required and the excess of heat that come from. When it comes to material, circular economy, we need to understand on how to handle in Italy something like 3,500 of e-waste truck by 2040. It is an enormous amount of materials that can be or can be not recycled. But what is important is that we need to be able to manage something that are exponential externalities. If we look in history on at all the business, once they have scaled to a critical size, they have faced increasing regulatory constraints. And I think it will be also the same for data center in the energy we are speaking about, but also in the material. Also, Patrizio provides few hints regarding the Bloom technology. And this risk is something that need to be properly handled. And I'm not sure that the business cases of the financials and the financial risk of the main developers are currently handling this kind of risk.
Now, Sandra, if you were advising policymakers in Italy or even across wider Europe in supporting greener data centers, what would you urge them to do first?
So, 3 main points. The first one is to have no barriers to local grids or internal grids, as we want to call them, and to on-premise generation. This is something that is related to regulation, allow to have efficient local grids that are able to leverage on-premises generation on a closer integration with renewable. It's also a matter of less taxes and tariffs to the local generation, to the on-premises generation. It is also a matter that considering that you're using a very efficient technology, that you're using a very sustainable technology, then on-site generation should be granted for a faster approval track, a waiver at least. This is the main point. The second, are we sure that district heating are the best solution to manage the excess of the heat, at least in the southern Europe? I take the case of Italy. Of course, we have some example from outside Italy, from Stockholm, from Luleå, in which there have been an integration with district heating. But when we speak about the southern Italy, we need to take into account some barriers. The first is the lower heat demand, especially in the summer, let me say. The second is the lack of cooling network. We have only heating network. The third is the high capacity, high capex of the new district heating network. We have a few district heating network, but not very large number. And secondly is the slow consumer switch from their own boilers to the district heating. How long does it take for a consumer to switch from a local boiler to a district heating is something that probably is not compatible with the business model, with the revenue model of a data center, which require an access to revenue that is really, really fast. On my side, the answer on this point is that we need to maximize the overall efficiency. Once again, on-premise generation is one technology, liquid cooling is another one. High efficiency power electronics is something that no one speaks about, but is another point. And also thermal energy storage could be a solution that we need to integrate. And this, let me say, also lead us to speak, to think more about what I called before data and energy hubs. The third point is that probably one of you know that in Italy there is a regulatory mechanism that was just put in place last year that allow for an accelerated permitting regime for certain kind of investments. What happened that the Ministry of Enterprise in Italy was overloaded by requests to leverage on this mechanism, and they are following now a first in first out logic. Probably is not the most wise logic. What we are advocating, what we are doing also lobby for, is to make in place mechanisms that are able to prioritize best practices. If you are a project that are able to lower the externalities, you are efficient, you are sustainable, you are not providing impact on the energy system, that you are granted for a waiver in terms of approval. It is a way to promote excellence. It's a way to promote new technologies into our energy system and data system, and to make at the very end Italy most attractive for foreign investments.
And Patrizio, if we look at on-site power solutions, fuel cells like those from Bloom Energy are one approach to deliver reliable on-premises power for data centres. How can on-site generation and fuel cell technology contribute to higher energy efficiency or even lower emissions for modern data centres? And for high-density AI workloads, what advantages do fuel cells offer compared to relying solely on the grid or even traditional diesel generators?
Sure. Well, on-site generation with fuel cell technology contributes massively to sustainability of the data center infrastructure. The Blue Energy Server is a 325 kilowatt module with 60% estimated fuel efficiency with no recovery system. If the CHP option is provided, the Blue Energy Server efficiency will go up to 90%, as the fuel cell will produce hot water or low pressure stream using the energy go out through the exhaust gas flow. And such thermal energy can be used to feed either an existing district heating network or the absorption chillers of the data centers. It should be noted that on-site power generation avoids the power losses in the grid transmission and distribution system that very often are not considered, but they are non-negligible. Okay, regarding the environmental impact, I guess I've already touched the low environmental impact of the Blue Energy Server, but it's always a pleasure for me to repeat that due to the fact the technology has no combustion, NOx and CO emissions are negligible. No emissions of volatile organic compound, unburned hydrocarbons, particulate matters, no methane slips, and CO2 is easy and cost effective to be captured. There are many advantages in using fuel cells for artificial data centers in spite of other technology. There are seven main points that come to my mind, but there are many others. Fuel flexibility. The fuel cells can operate on either natural gas, biogas, hydrogen, or any mix of these gases, which basically means that you can build a power plant right now using fuel cells and feeding the plant with natural gas, and if tomorrow there will be hydrogen available irrespective of how many quantity from 100% at whatever is available, you can basically fire these things in the energy server as it is with very minimal requirements and expenditures. While if you have to do this in reciprocating engine or gas turbines technology, it will be a massive expenditures. Low carbon footprint. I mean, that's compared with other conventional power generation, means, again, I'm not going to repeat myself. We are amazing. And scalability and rapid deployment. I mean, the Blue modular design allows for a phase implementation that can be tailored to the data center specific power requirements and integrated seamlessly with existing infrastructure. Resiliency and reliability. I mean, there are more than 1.4 gigawatt of Blue energy fuel cells deployed globally in more than 1,200 installations. And Bloom Energy can guarantee up to 99.999% power availability at any time during the operation, which is in some places higher than what the grid can guarantee. UPS quality power and precise load management. We don't have synchronous machines. Our power is generated by the fuel cell with a chemical process and managed by electronics. So the power generated by our energy server is UPS quality power. 2% per second ramp rate, which is the fastest available in the power generation industry, and millisecond response capability, matching the most stringent load variation requirements of the artificial intelligent data centers that other technology using synchronous machines are struggling to comply with. Power density, land is expensive, and so data centers try to avoid the use of lands. Just to give you a few data, when we use our tower design, the power density of the Bloom Energy technology is 3 times what is the power density of reciprocating engines, and more than twice what is the power density of the aeroderivative gas turbines, which are the more power dense rotating machinery. Bloom can deploy 108 megawatt in an acre, while aerogas turbines, they can place maximum 50 megawatt in an acre, and reciprocating engine maximum 34 megawatt in an acre. And last but not the least is the rental agreement. It's not available surely in the gas turbine business these days. Some of the reciprocating engine dealers are doing it, but Bloom Energy is offering to customers the rental agreement program, which is an operative leasing that does not require upfront investment by the customer, and the upfront cost investment for the equipment and the power plant is fully managed by Bloom, either directly or via a financier. And Bloom Energy will also take care of the operation and maintenance of the power plant. All is needed: people, spare parts, consumables. And with this program, the Bloom Energy solution will become a monthly invoice in the business model of the customer. And we see this in Europe because obviously we are not competing the grid. We are simply helping data center operators to deploy their own data center. And the typical duration for such type of rental agreement program is 5 years, which is the minimum time we have seen right now for a data center operator to get a letter from the transmission system operator telling them when the power will be available at the data center with no guarantee. So.
And Alessandro, data centers are often criticised for straining electrical grids. How might they become an asset to the grid instead of a burden? Do you think future data centers could stabilise the grid by adjusting their energy use, storing energy, or even supplying it back at peak times? What would take that shift to happen so that the data centers could support the wider energy system?
Yes, they are not only criticised. I know for sure that industry association like the Iron and Steel in Italy are really, really working in order to limit what will be the opportunity to scale up the data centers in Italy, because of course they are fighting for the same energy, for the same renewable energy. And of course it is something that needs to be taken into account. I'm providing you a few numbers, really high, and some scenarios. But every time in history that in which the industrial energy consumption reached a critical share in one specific sector, new energy models have arise, or were put in place at least. Let's think about the case of the industrial hubs in the 70s, the railways, the iron and steel industry themselves in the north of Italy at the beginning of the last century. All of those are cases in which there have been a very, very specific problem for energy. It was a real great opportunity for the country, and so we decided to join forces in order to provide an energy answer to these needs. In this case, the problem is similar. We need to put in place a different kind of solution, of course, but the problem is pretty similar. The political logic in which we need to adopt is really similar. At the same time, we need also to take into account that we are struggling for flexibility. In few months in Italy, we are going to publish a tender for the electrical storage with batteries that are only dedicated to the flexibility. And the most problem of these are in the central north part of Italy, and where our data centers are in the central north part of Italy. And so we need to stop thinking about the data center as only a data asset. We start thinking about the data center not only as a very concentrated load. We need to start thinking about data center as what we call a data and energy hub, in which you can integrate different kind of energy model, different kind of technologies, depending on the different situation, in order to provide an asset to the grid, in order to provide flexibility, in order to provide also clean generation where it is needed, and also not to provide a so heavy load. And this requires to integrate different kind of technologies, the possibility to use gas with CCS, so clean gas, to use renewable gases, to have very efficient on-site generation. This is key. To have also flexibility technology like the storage, to have an integration with on-site renewable generation. All of these are really small, let me say, bricks that help to build a different model, but also a different narrative. Data center will not be more and more considered like a nightmare for the grid, like a problem for the other larger consumer of energy. In TEA, in my company, we are working as a think tank, and we are involving the different TSOs, both the electricity and the network TSO, to promote those kind of new models, of course, that need to be designed on a specific situation in Italy. And we also need to work with the developers in order to make them understand that their business model in some case could change, and that there are technologies that could solve the current problem. As I say, the current problem of development of data center, in my opinion, is the main problem for the investments. We need to change these. Technologies are available, as Patrizio said. We need also to work to put in place an ad hoc regulation for sure that could incentivize. But if tomorrow data center want to start writing a new story, adopting a technology for competitive energy, for faster availability of energy, they can do it right now.
Thank you very much, Alessandro. Patrizio, following on from that, what does it mean in practice for a data center to operate grid parallel or even grid independent? Can you paint us a picture of what modern AI data center campus that generates most of its own power on site, say with fuel cells or other microgrid technologies, and how that setup benefits both the operator and the grid?
Yeah, I mean, the self-sufficient model is realistic at scale for large data center, and it has been implemented already in many places and under consideration for new data center infrastructure, even in Europe and in Italy. We have many applications in US, and we see this model proliferating in Europe as well. Grid parallel is another model used globally. In this configuration, the Bloom Energy Server can be used either for primary power generation as the primary power source, and the grid is used as backup power supply, Or, which is the model we see the most in Europe, the Bloom Energy Server is used as the always continuous operation, supplementing the power coming from the grid. Fuel cell with other microgrid technology is my favorite plant configuration, and I hope to see them as many as possible in Europe. This model allows the data center operator in using renewable energy sources, power coming from renewable energy sources when those sources are available, and maximize the use of fossil fuel that, in any case, is something that we should be using the next decade in Europe. So this is my favorite model.
And Alessandro, as a final takeaway, because I know we've got some questions flooding in, what one piece of advice would you give to the C-level and senior leaders listening today about preparing their data centers for the coming wave of AI? And what should they prioritize now to ensure they can scale up computing power while keeping energy use in check and also still meeting those sustainability goals?
First of all, they need to challenge their business model. Do they have a clear scenario what is going on in terms of there will be an exponential growth? What will be the impact of the improvement in the digital efficiency? Do we have an answer on that? And secondly, whether they are able, on one side, to face those kind of exponential opportunities, leveraging government technology, as we just spoke about the energy, but also whether they're able to face what we can say, some critical physical and regulatory barriers that could rise. Energy is one topic, but we have also the topic of resources, not only water, but also circular economy, and the territorial integration. In Italy, we are discussing a lot about the impact on landscape and so on. So this is my first point. Secondly, efficient technologies. Efficiency should come first. We spoke a lot about the fuel cells are the most efficient ones. Also take into account not only the contribution to your business model, but the impact or the lower impact on the energy system as a whole. You need to be much less impactful on that. And then there are also other technologies like liquid cooling that should not be longer merely a nice to have technologies for the largest, most modern data center. They are a critical necessity for all kind of infrastructure if we want to lower the impact on the external environment and if we want to achieve a faster integration in the system. And then I come to the point that we underlined several times: build a new kind of business models that integrate the energy aspect. You cannot longer just stay safe. Okay, the power connection will arrive. You need to take into account that you need to integrate different kind of technologies in your perimeter. You need to start being a producer of energy. That you have also the opportunity to increase your revenue by providing flexibility to the external environment, and this will increase the capacity that data center will have to integrate with the other networks. And of course, it is a matter to start different kind of relationship with the energy value chain as a whole. Last but not least, we need to create a larger partnership within the digital value chain itself. I see a lot of lack of efficiency also within the data center themselves, between who is producing the software, the hardware, and the data center. But more than this, if we create a stronger partnership, there will be the opportunity to explore new computational model that are able to increase the performance of data center while lowering also the energy required. Let me say, from here to the quantum, there are several kind of technologies that can be explored. We are working with the Italian Institute of Technology to explore some of these, and we are working also with some data center owner and developers to understand how to start testing those kind of technologies within there. But the capacity to deploy them, to define and explore them, come with a stronger industry integration within the data value chain itself.
Patrizio, final question comes to you. What's the key message for data center leaders aiming to power AI at scale? And is there a particular strategy or technology that you think that they should embrace today to meet the challenges of the next decade, both in terms of performance and sustainability?
Well, the key message is that the data center operators should not be discouraged by the lack of grid connections in Europe, nor the lack of power availability for them in the short term. They should consider and invest now in on-site power generation solutions meeting the same criteria they are using in the design of their own infrastructure: scalability, resiliency, flexibility, and sustainability. Using Bloom Energy solution for data center, they will be able to deploy their own data center now while waiting for the grid operator solving their own issues and providing reliable and sustainable power to the data center. Bloom is not competing with the grid. Bloom is the tool for the data center operators to deploy their own business quickly, as the way we live requires more and more data centers and data center with better performances.
Thank you very much. Right, I'm going to get to the question section because they are flooding in just now. Are fuel cells suitable for supplying AI loads which have cyclic load variations from 30 to 150%? And if yes, what consideration for operation is required?
Well, yes, the answer is yes. So, the fuel cells are, the Bloom Energy Server, because the fuel cell is the technology. And then what Bloom has done is, made that technology durable, and we have put this in architecture that is what the data centers needs. So, we have tested our energy server with load coming from NVIDIA GPUs, and this feature here, it is something that is part of our standard offering. It's proven, it's tested, and we are, I would say, the sole technology able to support the load variation, which is, technically speaking, a challenge for the other technology. But I will be willing to provide, more insights if the gentleman who has the question will connect with me, and we go a little bit deeper in the. It's a long technical explanation here, but the short answer is yes, and we have tested and twisted our energy servers exactly for this purpose, and we do have existing applications.
Okay, and another question from Paul, who's in North America. What is the largest Bloom installed to date?
Today, with the largest installed power plant is 80 megawatt, and it is located in South Korea. But we do have commitments in US and Europe for artificial data center above 100 megawatt. But again, the size is not a problem. They are kind of Lego blocks that you compose the power plant as many as you want. Again, if this gentleman will be so kind to leave his email address, we can start a discussion on this one. But short answer, 80 megawatt in South Korea, but there are commitments already taken for artificial intelligence data center above 100 megawatt.
And can you share the number of installations globally?
I said it's more than 1,200 installation sites. It's more than 1.4 gigawatt installed. And I would like to remind everybody that last year in November, 14th of November, we got a commitment from a company. It's a public domain information for 1 gigawatt of project for data center.
Okay, let me just see what else we've got here. Energy suppliers will grant connection if data center can guarantee operation with limits exceeding Annex 1 and Annex 2. due to operating limits with the existing power grid. Equipment suppliers do not design for operation at these limits, which may result in damage in case of sustained overvoltage. What solutions are available to address this incompatibility?
Yeah, this is microgrid. So this is nothing. It's something that we have done. No problem, as I told you already. Some of the project we do. I would say the majority of the project we have in Europe. The customer is getting power from the grid, and then we install the megawatt that are needed to supplement the grid and to fill the data center with the power needed. So this is one of the various microgrid options that are available. Again, if this gentleman would like to connect with me, Bloom will be willing to go deeper on this one. But again, not a problem. Done, doable, technically is easy. And we do have also installations.
Okay, I think we've got time for one more. Thanks for being a great presentation. Fully agree with Patrizio. Temporary fast track solutions will support on real time the demand. While the grid's not responsive to this demand, how do you foresee fast track mobile modular switchgears transformers being an added value?
Well, of course, we today, I would say today, the BOP equipment is needed to connect the Bloom Energy server to the data center. But again, it's something that we have in our portfolio, and we have, because the planning, we are never constrained or waiting for BOP components to put together our power plants. There is a lot of planning in what we do. Okay, so again, of course, if you don't plan and you go to the market buying BOP equipment, you will never get it. But if planning in advance as we do, and you will be getting the BOP when it's needed.
Thank you very much.
So the 6 to 9 months that I was mentioning is something that we can sign up, no problem.
Excellent. I also want to remind you that the Bloom Energy 2025 Data Center Power Report is available for download via the attachment to this webinar. Thank you very much. Can I ask you guys for your final thoughts? And just to anyone who has questions we didn't get to, you can reach both of today's presenters on LinkedIn. Any final thoughts before we close off?
So on my side, let me thank you all. Just a final conclusion, what we are doing in Italy. As I said, the topics on how to attract investment in data center is one of the central topics of the government agenda. And in this way, as a think tank, now we are serving other companies in order to promote solutions that are able to couple both what are the needs of the investor and the data center development on one side, and also lower the constraints on the grid and in order to accelerate investments. In the coming months, we are going to meet the different TSOs, the regulators, and also the government of Italy, also together with Patrizio, in order to promote the possibility to create test facilities together with the regulators, together with the TSOs, and also with the opportunity to attract investments under the European point of view, so the European contribution in order to test facilities. Of course, as a think tank, we are available to share all of this kind of information, and please feel free to reach out to me after this webinar.
Thank you. Final thoughts from you, Patrizio?
Well, first of all, I would like to thank Alessandro for helping us here. I work with Alessandro on this data center, and he's an amazing resource. I'm happy that we are able to talk freely about on-site power generation to almost everybody in Italy right now, institutions and developers. So I'm happy that there is an opening. And I'm also happy to see that I would say both the politicians and the decision makers realize that Italy has a great opportunity to host data centers, and we should be doing as a country everything needed to keep the data center in the country, providing what they need, and not let them go to other countries where they can get easier or cheaper what we are not able to provide them. So I'm very encouraged for what I've seen. And I would like also to thank everybody for spending this hour with us. And as you said, if you guys want to connect, just use our LinkedIn profile and we will be willing to start working with you.
Alessandro, Patrizio, thank you very much for your time and thank you for joining us for this webinar. Just a reminder that you can watch the full webinar in full on the Capacity Media website after it's finished. Thank you, everyone.
Thank you, everyone.
Thanks.